Hey guys, welcome to lesson 2. This is the kind of a continuation from what we've been doing even from last unit. But if you have any questions at any time, please do not hesitate to message me, call me through Teams, whatever. And I've got it set up now where I can show you visually how to do certain things, so that should be helpful. Okay, let's start out. You can try these warm-up questions on your own if you'd like, and then you can check your answers and follow along if you'd like. So the first one here says, find the exact values of cotangent x equals -1, 0 between 0 and 360 degrees. So first thing we should do is to switch this into tan. So tan of x. If I flip -1, -1 is really -1/1. So if I take the reciprocal, it's just the same. And so this becomes -1. In this one, it's actually one of our special triangles. If it was sine -1 or cosine -1, it would be one of those special cases where it's 0, 90, 180 or whatever. So, but this one, remember when I have the 45, 45, 90 triangle, I've got 1, 1, and root 2. Well, tangent of 45 would be 1/1. So in this case, our alpha, the related acute angle, is 45 degrees. So if I just sketch that out, oops. Something like that. Oops. And because it is a value that is negative for tan, so I have to think, okay, the cast rule, it's negative for tan. So where is it going to fall? It's going to fall in the S and the C quadrant. So I can go ahead and draw it there. I got one there and my second one down here. And I know that alpha, the related acute angle, is in here. And what I want to do is find what is this. So let's call that theta 1. So theta 1 would be 180 minus the 45, or 135. And then my second angle is going to be this one. Let's call it theta 2. Theta 2 is going to be 360 minus the 45. So I end up with 315. So there's my two answers. So again, if it was sine or cosine -1, then you would be dealing with one of those special cases where you do sine equals y or cosine equals x. The next one's just using your calculator. And it says secant of -145 degrees. All you have to do with these ones is you flip the whole thing. So it's the reciprocal value, oops, and secant matches up to cosine. So I take 1 over cosine -145, and that's approximately 1.2. Those ones are a bit tricky just to remember what to do. Next one's going to require a fair bit of work. This one says find the exact value of this expression here. So really, it's like you've got 3 different questions you've got to do. You've got this one, and this. And then you can try to put it all together at the end. So let's start with the first part, cosecant 240. So cosecant 240, cosecant matches up to sine. And sine 240, you may have to do a little sketch here if you're not confident about what you're going to get. So 240 would be here. And you can see why the special angles become so important to know, because they're always just going to pop up in different places. So in this case, theta would be 240, or sorry, alpha would be 240 minus 180, which is going to be 60 degrees. So that means I'm really getting the sine of 60 degrees. And if this is 60, then opposite 60 is root 3, only it's going to be negative, and the hypotenuse is 2. So this 240 is going to be minus root 3 over 2. Therefore, cosecant is the reciprocal of that. So I just flip it so it becomes -2 over root 3. And then if I rationalize the denominator, I'm going to get -2 root 3 over 3. So that's the first one. Again, the more you do, the quicker you'll get at doing that. So if you needed to, you can always back that up and rewatch it. Second one here is secant 135. Secant matches up to cosine. Again, if you need a sketch, you can do it. So we're somewhere here. So that's 135. So alpha is going to be, hopefully you just see that, that's going to be 45 degrees. So remember, we're in this quadrant though, so it's going to be negative for cosine. And cosine has a -1, or 1, it's going to be negative there. This is 1 and this is root 2. So this one's going to be cosine of 135 is -1 over root 2. Or if you, well actually we'll leave it like that, because therefore secant of 135 is going to be the reciprocal of that, which is -√2. So that's that one. So we've got our answers here. This one, and now we just need this last one, which is tan. So it's not a reciprocal, obviously, so we can just do this normally. So I've got 330, so somewhere here. If that's 330, then hopefully you see this is 30. Opposite 30 is 1. Adjacent would be root 3. That's my 90 degrees. So tan of 330 is going to be, this is -1 over root 3. And if you want to, you can rationalize that denominator. I'm going to leave it for now. Okay, so there's our 3 things we're going to work with. So down here, we can do this all out. So cosecant 240 over secant 135 times tan 330. Okay, so I got to start to plug these things in. And so cosecant was -2 root 3 over 3. And this is going to be divided by secant. So I'm going to write it like this. So it's divided by -√2. And then we're times the tangent, which we said was -1 over root 3. So if I work that out, when I divide this second one here, the root 2, it's really like multiplying by the reciprocal. So I can just simply flip that. So it's times 1 over -√2, like this. So when I do that, I'll just do the first 2 fractions. And then so I get -2 root 3 over 3, -3 root 2. So obviously my negatives are going to go away there. And then I've got this last part. So why don't we put that all together? Notice here I've got root 3 on top and root 3 on bottom. So those can just cancel out. So then I've got the negatives gone, but I've got 3 negatives, so I'm still going to have a negative overall. So I've got 2 on top, and on bottom I've got 3 root 2. And then I can just rationalize the denominator. I should have a negative there. So I'll multiply the top and bottom by root 2. So you end up with 2 root 2. I'll move the negative up. And this is going to be 3 times 2, which is 6. And that actually can be simplified just slightly because 2 divided by 6 becomes 1/3. So this becomes -√2 over 3. And that's it. So that's a pretty tricky question. That's a lot going on there. And a lot of algebra in the end. So if you need to, you can rewatch that. As long as you can get these 3 beginning parts here, I think that's really the key component to all of these. Okay, today's lesson we're going to look at, again, it's kind of an extension on what we were doing before, only it does get a bit more complex. In fact, it gets into a lot of stuff that you're going to eventually do in advanced functions. And so it's called solving trig equations. And so what you're trying to do, again, is find angles. So our variable is going to be likely theta, so we're looking for values for an angle. So if we dive right into the first one, it says solve the following for theta, given the domain without using your calculator. So the first one here, we've got 2 sine theta equals root 3, so those numbers should look familiar. And then this is really just over 0 to 360. So if I want to solve this, my variable is theta, so I'm trying to isolate for theta. So I need to move whatever I can to the other side with the root 3. So the first thing I can move is the 2. So the 2, I'm going to simply divide because it's 2 times sine, so I'm going to divide it over to the other side. So now I have something like you've seen many times already. So I have this expression root 3 over 2. So it's sine. So what I can find, just like normal, is theta. So theta is going to be the related acute angle. And if you, again, imagine that's a triangle, there's 90, let's say that's 60 and 30. This is 1, root 3, and 2. It's going to be 60 for sine. So theta gives me, or alpha gives me 60. And using the cast rule, I've got sine as being positive. So this is a positive root 3 over 2. So that means I'm here and I'm here. And so I can draw my little triangles, my quarter of the bow ties. And I get and I'm just going to put in 60 here because I already know it. So one answer is in fact just 60. So 1 theta, let's call it theta 1, is 60 degrees. And then the second one is just going to be 180 minus the 60. So 120. So there's my 2 answers. So again, nothing too crazy from what we've seen already, but it will get a bit more difficult. Next one here. Now I've got negative sine theta on one side, and I've got another sine theta on the other, plus 1. So what I want to do is get all of my sines to one side. So I'm going to subtract the one on the right over to the left. So I'm going to get negative sine theta minus sine theta, which is negative 2 sine thetas equals 1. So again, trying to isolate for theta, I need to divide both sides by the negative 2. So I get negative 1 over 2 here. And now we try to isolate for theta. So we go through our process. Alpha in this case is going to be, if we look at the triangle we had here, I've got 1 and 2, so this is going to be 30. And the next part is to use the cast rule to decide where it is, in which quadrants. So I got negative for sine, so that means I'm down here and I'm down here. So I've got this triangle and this triangle. Again, we can put in our alpha, 30 degrees in those, and find thetas. So theta 1 is 180 plus 30. And then theta 2 is my 360 minus 30, or 330. Great. So again, nothing too crazy. Let's try the next couple. And again, you could try these on your own if you wanted. This one's not too bad either. Again, isolating for theta, I'm going to move the 1 over, and I'm dividing by 2, or root 2 rather. And so this time my alpha, again, if you look at the special triangles, this is the 45 one. I know that because I've got this root 2 in the equation and a 1. So the related acute angle is going to be 45. Notice here there's a bit of a trick. They're asking in the question to go between 0 and 180. Before, they were asking for between 0 and 360. So in fact, if I think of where cosine is going to be a positive number, it's here and here, but we're only using the top region, so nothing down here. So this one's actually pretty simple because I'm only using this quadrant. And so my theta is equal to 45 degrees. And again, it's because they've specified this thing here, 0 to 180. So that's it. Next one's a bit trickier, and I want to explain this notation here. We've got tan squared x minus 3. And again, they've kind of done a little trick. It's between 180 and 360. So tan squared x is the same as if I went like this. It's the tan of x squared. There's a reason we don't write it. If I had to write it like this, mathematicians are lazy and they generally don't write it like that. That is the same as what we see. There's a reason we don't write it like this, because this would imply that x is being squared. And so generally we write it just as you see it in the question, where you've got tan squared x. So let's try to solve for x in this case. So the first thing I can do is move the 3 over to the other side. So this becomes positive 3. The next thing I can do is I can take the square root of both sides. And what that's going to do is get rid of the squared for tan. So I now just have tan x. So when I take the square root, easy to forget, but I should take the plus and minus of both sides. So that's going to be plus or minus root 3. So in this case, because they're only asking between 180 and 360, it means my answers are just going to fall from down here. But because it's the plus or minus, it means it could be any of these. It's really all of the 4 quadrants, but I'm really just going to focus on these 2 for tan. So if I think about alpha, so approach this just like you normally would. So alpha being root 3. So I need to figure out opposite of root 3 is 60, so that means this is going to be 60. So I've got answers that are going to fall in these 2 quadrants, and it's positive or negative for tan, this thing, so it means it could actually be in either. So again, a bit trickier. So I've got my alpha, so theta is just going to be theta 1, it's going to be 180 plus alpha, which is 240. And then theta 2 equals 360 minus 60, which is 300. So there's my 2 answers. And I only go in those bottom 2 because they've stated this. It's between 180 and 360. Okay, the next couple are quite a bit trickier. And it's really just an introduction into what you can do with solving trig equations. But this one, if you look at this one, I've got sine squared x minus sine x equals 2. So I would not expect many people to be able to get this without me showing it to you. The first thing I need to do is I need to move the 2 over onto the other side. So it's all equal to 0. So looking at this, that looks a bit crazy, but this is really a quadratic equation. With quadratic equations, it means you're going to get 2 possibilities for sine. And the easiest way to approach this is to get rid of the sine, actually. And I'm going to say let A represent sine of x. So I'm going to replace sine x with A. Once you see it like that, it might be a bit easier to figure out. So what you do is you say, okay, A squared. I have no x because I've let A represent sine of not just sine, but sine x. So this becomes this. And then I've got minus sine x. Well, that's just A minus 2 equals 0. So now you have a quadratic equation that you probably recognize and can factor. So we say we need 2 numbers that multiply to give negative 2 and add to give negative 1. So if I work that out, that's going to factor into x minus 2, x plus 1, and that's equal to 0. So I say, okay, I set that equal to 0, so x equals 2, A equals 2, and A equals minus 1. So now I go back and say, okay, well, that's just this. It's sine x. So I say sine x equals 2, and sine x equals negative 1. So that process is completely new for most people, and it comes in handy when you get into more complex things that are represented by longer variables like sine or some expression that has more than one variable. You're going to use that when you go on in math. So again, it's new, but we end up with two separate situations for sine. So when I go to solve this, like if I was solving for x now, I would say, okay, here it's equal to 2. I would punch that into my calculator, the inverse sine, and what happens is this one actually is an error. Because sine of a value of ratio of sides can never be greater than 1 because the hypotenuse always has to be larger. So you can try that on your calculator. This one, again, it looks like an exact value question. And this is a special case because we've got sine of x equal to -1. So remember sine, so I'm just going to write recall. Sine is equal to the value of y. So you have to ask yourself, where on the unit circle is y equal to -1? So remember over here, this is y equals 0. This is y equals 1. This would be y equals 0. And down here, we get y equals -1. And so down at 270 degrees is where I'm going to find this angle. And so therefore, x equals 270 degrees. So that's this angle here. And so I'm just going to write it here just so we have it. Like that. And so we've really actually only got one answer for this whole question, and that's 270 degrees. So there's a couple parts that make this tricky. The first part, which I explained, but then also this part, which is that you've got this weird extreme value that I talked about in the first lesson, where it does work out so you get a value where you have to think of just y. Okay, the next one here, I think on your handout, I've replaced this with theta, and that will make this a bit easier. So those are all thetas. So if I go through this one, again, we've got something similar to before, only, so I'm just going to rewrite it. 2 cos squared theta plus root 3 cos theta equals 0. So this one isn't necessarily quadratic, but it's something that can be factored. And that's what I'm going to do here. So if I wanted to factor this, there is a common factor of cos theta. The first cos squared theta has the square, right? And so I can take a cos theta out from everything. So I'm going to write that. Cos of theta, bracket. It's just like factoring any variable. So that's going to leave from here, I'm going to have still 2, obviously, and then a cos theta. Because cos squared theta divided by cos is just cos. So then I've got plus, and then in the second one here, it's only left with root 3. And so that's what we've got to do in order to figure that out. You could use the let A represent cos theta if you wanted, but because it's only one step, I think it's fine to do it this way. So similarly, now I need to say, okay, cos theta equals 0. So that's one situation. And then this one I need to solve separately. 2 cos theta plus root 3 equals 0. And then I do what we were doing before. I try to solve for cos. So I move this over, so that becomes negative root 3. And then I'm going to divide it by 2, like that. Okay, so we've now got two separate situations that we need to solve. The first one here is one of those extreme cases, just like what we saw in the previous question. I've got cos theta equals 0. So I have to say and think about cos theta is really just x. So I say when on the unit circle is x equal to 0. So really, here and here on my unit circle, x equals 0. So theta is going to be, one answer is 0. And the other answer, so this is 0 degrees, the other answer is 180. The only other thing is that this could also be 360 degrees. So from this special case, theta equals 0, 180, or 360. So I actually have 3 answers from that one part. So there's the first one. Second one, we've done lots like this. So I say, okay, what's alpha? So I've got an exact value. Alpha is going to be, and you can draw this out if you want, oops, is going to be 30 degrees. And looking at this, it's a negative value. So I say, okay, cosine being negative is going to fall where? Here and here. So I'm going to have something here and here, where alpha, which we found to be 30, is these two right there. Okay, so then I've got theta 1 is going to be 180 minus 30, so 150. And then my second answer in this case would be theta 2 equals 180 plus 30. So 210, like that. So hopefully that part isn't so bad. So we should say therefore theta equals, in this case, 5 different possibilities. 0 degrees, 150 degrees, 180, 210, and 360. So a lot going on. Very tricky. Those are some of the hardest questions, and you will see more of that in grade 12. But it's good to see them now. So if you need to, I will definitely help to explain those more in our extra help session at the beginning of class. So you can try out these try questions. There's a couple there. They're not too bad, and I don't think they need a lot of explaining, but you can go through them. And then you can try these questions for your homework. Again, I will start off the class